going to start here on day 3 with our special quadrilaterals, trapezoids, and kites. So a trapezoid is a quadrilateral with exactly one pair of opposite sides that are parallel. That exactly one is very important because if we even just focus on a regular parallelogram, it also has one pair of opposite sides that are parallel, but in the case of a trapezoid, this has exactly one pair. Our bases of a trapezoid are going to be our parallel sides. Legs are our non-parallel sides. Our base angles of a trapezoid will be those angles that are formed between the parallel sides and the legs. An isosceles trapezoid has two congruent legs. Make sure that those are marked if you use them. Much like an isosceles triangle, in an isosceles trapezoid, the base angles will be congruent. So if we take a look at this example here, then these two base angles would be congruent, and these two base angles would be congruent. Our mid-segment of a trapezoid is the segment that connects the midpoints of the legs, and a kite is a quadrilateral with two distinct pairs of consecutive congruent sides. So the reason that we want to have that two distinct pairs of consecutive congruent sides is because a rhombus also has consecutive congruent sides. But what you'll find in a kite is that the pairs of congruent sides are different lengths. So in an example just like that. If a trapezoid is isosceles, then each pair of base angles is congruent. Just as I marked in the photo up above, angle B and angle C would be congruent to one another, and angle A and angle D would also be congruent to one another. Also keep in mind that because we have two parallel lines, that angle B would be supplementary to angle A, and angle C would be supplementary to angle D, whether this is isosceles or not. If a trapezoid has a pair of base angles congruent, then it is an isosceles trapezoid. A trapezoid is isosceles if and only if the diagonals are congruent. So while they are congruent, one thing that you want to make sure of is that while AC is congruent to BD, that they do not bisect each other. Because if they were to bisect each other, it would not be possible for this to be a trapezoid. It would have to be a parallelogram. So if we want to show that something is a trapezoid, pretty much all we need to show is that two of the sides are parallel. So if I look here, and let's find the slope of DE. So up 1 over 3. And the slope of CF. Up 1 over 3, up 1 over 3. So because DE is parallel to CF, then quadrilateral DEFC is a trapezoid. So the mid-segment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. So if I want to take a look at the length of MN, it is going to be the sum of AB and CD over 2. So the length of the mid-segment is the average of the bases. So think back to our triangle and our triangle mid-segment. If we had a triangle and we wanted to find the length of its mid-segment, remember that it was half of the base. So if you think about that same thought process, isn't this top base have a value of 0? So it was still essentially the average of the bases, but one of the bases happened to be 0. So if I want to find the value of mn, in this case over here, I'm going to do 16 plus 9 over 2, which is 25 divided by 2, and 12.5 inches. Don't forget your units if they need it. If a quadrilateral is a kite, then its diagonals are perpendicular. And if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. And the last thing here, if a quadrilateral is a kite, then the non-congruent angles are bisected by the diagonals. So let's draw a kite here. I'm going to draw it vertically. Remember that we have two pairs of consecutive sides that are congruent, but that they are congruent in different ways. So here, to take a look at the first part, our diagonals will be perpendicular. This kite probably is not perfect, but it'll be close enough. So here is our perpendicular diagonals. It also tells us that exactly one pair of opposite angles are congruent. So if we just take a look at these triangles here, I'm going to highlight this. Then our congruent angles, if we're thinking about our triangles, will be this angle and this angle. These will be congruent. And if one pair of angles are bisected, again, think about this as them being congruent triangles, then these two angles at the top are congruent, and these two angles at the bottom are congruent. So these two angles here are all congruent, but then our long diagonal is going to bisect in the angles that it reaches. So if we want to classify this quadrilateral and find the measure of angle T, I know that by the way that these are marked that this is a kite. And I also know that everything should add up to 360 degrees. So if I do 360 minus 70 minus 88, that gives me 202. And I know that also angle R is congruent to angle T. So I'm going to divide that 202 in half. So this would be 101 degrees for both angle T and angle R. Quadrilateral WXYZ has both pair of opposite sides congruent. What types of quadrilaterals could meet this condition? So if I have both pair of opposite sides congruent, think about what we can use to prove here. I cannot have both pair opposite sides congruent in a trapezoid. I can also not have both pair opposite sides congruent in a kite, but I can in a parallelogram, which then would also include our square, rhombus, and rectangle. If I want to classify the figure ABCD based only off of what I see, remember we cannot assume 90 degrees, so make yourself a note here. Never assume 90 degrees. Even though this looks like a square, and it probably actually is a square, the only thing that I can assume here is that I have 4 congruent sides. which then makes this a rhombus. It will be a parallelogram, but even more specific, rhombus with 4 congruent sides. Is the given information enough to show that FGHJ is an isosceles trapezoid? Why or why not? So remember that we need base angles to be congruent. So if I take my 360 and subtract all those angles, I do end up with 78 degrees. So yes. The other thing to consider is that if I add 102 and 78, this gives me 180 degrees. So I also know that those two sides are parallel to each other. And because my base angles are congruent, yes, it is an isosceles trapezoid. So we're given quadrilateral ABCD with these vertices. Classify the quadrilateral without using graph paper. So this is where we're going to use the attributes that we have. I like to usually check with slope first. So the first thing that I'm going to do is just kind of draw something out and label it A, B, C, D. Remember that these letters need to go around in a circle. It doesn't really matter which direction you take these letters, but we just can't zigzag across the figure. So let's check slopes first and determine broadly if this is a parallelogram. And if we'll go ahead and check the slopes, that would help us to narrow down whether or not we have some perpendicular sides, which could lead us to a square or rectangle. So let's find our slopes of all 4 sides. Slope of AB is going to be 6 minus 4 over 3 minus 1, which gives me 2 over 2, which is 1. Our slope of DC is going to be 1 minus 5 over 2 minus 6, which is a negative 4 over negative 4, which is a 1. So I do know for sure that AB and DC are parallel. Let's check the other two. So the slope of BC will be 5 minus 6 over 6 minus 3, so negative 1 over 3. And the last one, the slope of AD, will be 1 minus 4 over 2 minus 1, which gets me a negative 3 over 1. So while AB and DC are parallel, the BC and AD are not, so this at least gets us a trapezoid. Now, I can stop there if I can't get any more specific, but in this case I can. So what we want to do is go ahead and see if our trapezoid is indeed an isosceles trapezoid. So what we need to check is our distance for AD and our distance for BC. So if we start here with AD, remember that for distance we take and we subtract our x's. So 2 minus 1 squared plus 1 minus 4 squared. 2 minus 1 squared will give us 1 squared plus, this will give us negative 3 squared. 1 plus 9 will give us the square root of 10. And now if we go ahead and check our other side, which will be BC, I'm going to have the square root of 6 minus 3 squared plus 5 minus 6 squared. And that will give me 3 squared plus negative 1 squared, which will also give me 9 plus 1, which is the square root of 10. These have the same length, so I have one pair parallel sides and one pair of congruent sides. This is not the same set of sides, so my pair of parallel sides is AB and DC, and my pair of congruent sides are AD and BC. Remember, if they are the same pair of sides, then we don't have a trapezoid, we would have a parallelogram. But in this case, they are different sides, so we have an isosceles trapezoid. Another way that you could check to see if this was isosceles is check the length of the diagonals. And if the length of the diagonals was the same, then it would also be an indication of it being isosceles.